Hi, my name is Natalie Leger, and I'm going to be explaining the genetics phenomenon known as epistasis. Epistasis is when the expression of alleles from one gene mask or modify the alleles from another gene. So this is an interaction between two different genes or two different loci, resulting in a specific phenotype. So there's many different types of epistasis. So this chart is depicting just 6 versions of epistasis. It's saying that these genotypes here at the top have different phenotypic ratios for each type of epistasis. The reason they're changing is because they're all versions or modifications here seen at the top of the Mendelian ratio. So the Mendelian ratio is from Gregor Mendel, a dihybrid cross, and it's F2 progeny. So today we're going to be talking about duplicate dominant epistasis. So this occurs when you have the functional dominant alleles from either loci, and these functional dominant alleles are going to result in the exact same phenotype. So we can either have both or just one, but they both are the same thing. So if we don't have either, and instead we get homozygous recessive alleles at both loci, then we will get a different phenotype, but that's rare. So for my example, I'm going to be using North Carolina peaches. And this is going to be done with a orange phenotype being converted into a pink phenotype. So this is done with our functional dominant alleles, also seen here as enzyme A and enzyme B. But say we don't get one of them, and instead we have a homozygous recessive allele at the A loci. Well, that's okay. We have enzyme B to get us our pink phenotype. But what if we have both? So then they're going to come together, strengthen numbers, and give us our orange phenotype. They're going to inhibit this conversion from orange to pink. So what does this look like when we look at our genotypes? So this genotype is crossed with itself, and these are its different combinations of alleles. So put into a cross plot, we get these different allele combinations in the F2 progeny. The F2 progeny are going to have a specific ratio known as the Mendelian ratio, and this is going to have a specific phenotypic ratio because we know that the dominant functional alleles, either both or just one, are going to get us our pink phenotype. So that gives us a 15-to-1 ratio. You can see the orange is a little bit upset for being left out. So let's look at a different genotype combination. So these are allele combinations, so a little bit different this time, not as many. And when we put them into a cross plot, we get these allele combinations in the F2 progeny, which gives us this ratio, and we're just going to have pink. And these are my citations. Thank you very much.